need to use a pump, we use them because we need to increase the mechanic energy of the pump. There is an inlet of energy, mechanical energy to be precise, and we either use it to increase velocity of flow, to increase a height. For example, if you have water here, you want to increase the height of the water to another reservoir, well, that's not going to happen alone. You need to add work. And more importantly, you use it to increase pressure, to pressurize. Pressure is essentially the ability of a fluid. You have high pressure here, then this point is low pressure. Well, expect it to move from low to high pressure. Once again, fluid density does not change, and this is very critical for the pump operation. If it changes, you will have problems in the impeller, and eventually you're going to destroy your pump. The main classification is positive displacement pumps and kinetic pumps. As the name implies, this is due to the movement of the pump or the inside material or pieces. We have rotatory, which the name implies are pieces that are rotating, and reciprocal. These are a little bit more tricky, but they are also useful. For example, diaphragm. Now for kinetic pumps, we have two typical one axial. This is pretty similar to turbines. You have many blades which move. On the centrifugal, you have only one impeller, which has this here and starts moving and pressurizes the fluid. We need to study all the stuff that is behind this pump. For example, there is a motor. You need to move a motor. It's going to move, and of course, this is the inlet, and then it goes out in the outlet. So we're going to check out a little bit on the common pieces and parts and operation of the pumps. We need to know the fluid type, if it's viscous, it's not viscous, is it it vaporizes very easily or is very stable, and it has some maybe solid parts, or is it only fluid, liquids, and so on. Also, of course, you need volumetric flow rate. If you have a very huge volumetric flow rates, you will be probably using a centrifugal pump. You have very low very low volumetric flow rates, you're going to use maybe positive displacement pumps. You need to know definitely the suction conditions, which is pressure, temperature, pressure because we might, let's say, have a very low pressure, and therefore you will not be able to operate it, because when you get this into the eye of the pump, it's going to evaporate and will cavitate your pump. Composition as well. And discharge actually is not that important, but also you need to know the discharge conditions. Obviously, you're going to have a high pressure fluid with normally a high temperature, because pressurizing means increasing temperature, and you may even change the composition depending on the vaporization of the elements. Well, also you need, of course, to know how the system is set, so how much energy, pump, or head requirements. For now, we're going to use head, which is essentially how much pump requirement do you need. And one thing is to know the head. For example, if you recall, it's joules per kilograms, or you divide it by gravity, you're going to say meters. But eventually you want to know that on power, or how much energy you're going to use per unit time. That's power, so horsepower, or even watts, which are essentially joules per second. Also, this is important, you need to know about spacing. Maybe you have find the best pump ever, but it won't fit your, I don't know, maybe it's a small area, or maybe you don't have that much space, so it won't be the best pump for you to operate or install. Dimensions, that's also important. Maybe the weight, maybe you're going to use it in a platform and you have it very, let's say it's very heavy, therefore you shouldn't use it because you're going to bend the platform or so on. You need to know the cost of buying it, that is the investment cost. How much does the pump cost? Is it worth it? It's going to, let's say, in the future it's going to be useful, or you're just going to waste your money. And operation costs. Many pumps are very nice suited for the business, Many other are not, because they're going to be, let's say, having a high cost of operation. Even though maybe it was cheap, well, yes, it was cheap, but operating the pump is very expensive. For example, maintenance and installing and uninstalling, maybe also how pump requirements decrease, maybe the efficiency decreases with time faster, and many other criteria will be also important. Maintenance costs, I already told you. The type of pump you want to use. Many times you want to force a, for example, a centrifugal pump, even though it might not be the best pump type to use, but it is the only one you have. So guys, one thing you get when you subscribe or enroll to any of my courses is a premium membership. And what do I mean with premium membership? Is essentially that you are my priority member. What does that mean? Is essentially if you send me an email or if you post a question in any of the practice, course, or even quiz sections, I will answer you as soon as possible. And that is a thing I don't usually do in YouTube. I love answering questions in YouTube, but you are now my member, you are my student, you want to learn, and I want you to learn in this course. So whatever doubt you have, you can send it either via email or post it here in the questions, and I will answer you as soon as possible. So you need to, let's say, be able to use it, install it, and understand it and operate it. The supplier is also very important. Does the supplier is a well-named brand, or is it very cheap one, or maybe the supplier has very short lead time? He will definitely give you the pumping in 1 month or so, or will it take 3-4 months? Well, that's also important. You need to know and be confident with your supplier. Sizing and type of connection, that's very important as well. Many times you have many pumps such as these that change the diameters. Well, that's actually no problem. Recall from the last section we've seen before, we can use sudden expansion equipment or fittings that will force the pumping pipes like here. Because you're gonna change the pump, it's already fixed, but you can't also change the pipe because you already have it. So the only thing you can do is to add a expander and a reducer right here. Also, you want to know the revolution per minute that your pump is operating and the frequency. That's very important. Frequency is measured in hertz. Actually, we have different, especially in America versus USA, versus Europe. You have different common frequencies of operation. That's more into the electrical engineering part, but still important. The impeller, what type of material is it? Steel or is it iron? What's being used? The diameter is also important. The size, the angle, all those, the shape of the impeller is very important. Pump material as well, and the minimum and maximum discharge and suction pressure. So what is the minimum operation pressure right here and the maximum operation right here? Is it suitable for your operation or even for your pipe? Is it safe or is not safe? You need to check out that as well. So yeah, that was the common things you need to know for pumping, or at least for the pump. And as I told you before, we have centrifugal ones, and we got many type of turbine type, the impeller sizing, what is it, impeller, and so on. Let me show you the types of pump. Actually, it was just an introduction, but actually let's start with the type of pumps. You know, there are pumps, rotodynamic, which I told you is rotatory, and the positive displacement pumps. Here. These are the kinetic ones I told you before. Centrifugal pump is the most common one used. Avoid this one. And the axial pumps, which are like turbine-like pumps. Then we have the positive displacement pumps, which is reciprocation and rotatory pumps. And then you open, well, we have axial pumps actually right here, but centrifugal pumps we have a lot. Actually, is all these right here, all these types. Rotatory pumps, we have screw, slide pumps, rotor pumps, gear pumps. We're going to check them, each one of them later. Reciprocation pump is either piston or plunger pump. And Centrifugal pump, as you can see, there are many types: pressure, by flow, and impeller, casing, installation, and so on. All these criteria: open, closed, etc. So for rotatory, we have many. Rotatory right here. Rotatory pumps. So let's analyze. We have vane pumps, piston pumps, low pumps, gear pumps, screw pumps, the most common ones. For centrifugal pumps, we have right here either radial flow, axial flow. We don't want axial flow, we want right now radial, single suction, double suction. There are many single stage, multiple stage. Actually, we're going to study single stage and multiple stage. Well, there are many pumps. Yeah, essentially that's what I wanted to show you, that there are many pumps. We're going to start analyzing the most common ones and how do they work. So hopefully you like the introduction to the type of pumps, and see you in the next videos. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, and then you have the sections. If you're, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. You were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.